Hello, welcome. This is microprocessor online class. Now I starts with 8086 assembly language programs. So these are the list of articles. The axis number 1, 8-bit arithmetic operations. Under the 8-bit arithmetic operations, there are 4 operations like addition, subtraction, multiplication and division. And 16-bit also addition, subtraction, multiplication and division. Then string operations. The axis number 4 is the block operations. Then axis number 5 is bias or DOS interrupts, that is rename a file and keyboard interrupt, keyboard input and password. So these are all the list of articles. We will see one by one. Now in this video I just explain 8-bit arithmetic operations. So first we go to open one text editor. So here I start with, this is the command line for 8-bit arithmetic operations. 8-bit arithmetic operations for 8086. This is the command line. First start from dot model is small. So this is known as memory model. Dot model is a memory model, so which instructs the assembler and how memory should be arranged. Because of the dot model, it contains for small, that means it will take one data segment, code segment and a stack segment, only one. Okay, so that is the meaning of dot model small. Next, dot stack 100H. So this is another directory which is a label to define the position of the stack. The entire stack memory is 256. Now I define only used for 100H. That is the use of dot stack. Next line, dot data. So this is for data segment, which indicates the variable storage section, or to declare a variable from the data segment. Here you can declare the variable, that is n1 db for declare or define byte. The first data 0 cdh. So CD is a data, that is a hexadecimal data, that's why I'm putting H, that is 0 cdh. So CD is a 1 8-bit data, that is 2 bytes are there, sorry, 1 bytes are there, that is 8 bits. Next, n2 for next data to define 85H. This is also a hexadecimal value, 85. Next, to sum these two values and store define word, that is DW for define word. This is 16-bit data. For after adding these two 8-bit data, that is CD and 85, it stored 16-bit. That's why I'm taking DW and question mark. Then next, code segment, dot code, that indicates the start of the actual assembly language code. Okay, here I want to start the assembly language code. Then coding begin. The first line of the program, move ax comma at move ax comma at data. So this is the first line of next move ds, that is a data segment comma ax, that means the content of ax will be move on ds. Before move ax at data, that is to indicate the data to be move on ax register. Next, so these are all the two service number, move h comma 4ch, this is one of the service number. Another one int 21h, then end of program, that is end begin. So these are all the two service number. Int h comma 4ch is the first line of the assembler code. The value 4ch, that is the hexadecimal value which is move on to or which is stored on to h register. And one more service number is the int 21h. This is the second line of assembler code. This interrupt causes the program to exit immediately, that is DOS command, exit to DOS command, then end begin. Okay, so this is the structure of 8086 program. Now I incorporate the logic of this program for adding two numbers to 8-bit data. So first we take move ah comma 00, that is the age register is 0. Next move al comma n1, the content of n1 will move on to the lower order register, that is al. Then ah is higher order, al is lower order. For both al and ah contains ax register, that is 16-bit data. al and ah is a 8-bit register. Next, add content of al comma n2. So before in content of n1 is move on to al, that means cd, the content of al is cd. After that add the content of cd and 85. Okay, the result will be stored on ax register, that is a 16-bit register. After that, suppose if you have produced any carry, the carry bit will be stored on adc, that is add with carry, higher order register h comma 00. Then finally it moves move sum comma ax, that is the sum of data is stored on ax, which is moved to sum. Okay, so this is the addition of two 8-bit numbers. Now go to save. C colon, under the C colon masm e086. Here I want to save the file name is sys number 1.asm. Please check into all files. So it has saved under the folder MASM 8086. Now save it. Now go to open DOS bus. This is the command prompt. After that, to mount the path, that is to mount C colon space slash MASM 8086 to locate the file, because I am storing the ASM file will be MASM 8086 folder, so it will be located. If the path is successfully, we got the message drive C is mounted as a local directory. Now it changed the directory, that is C colon Z to C, that is C colon. After that, MASM file name is access number 1.asm, then enter, put the semicolon, it will be compiled. So here 0 warning, then 0 severe errors, that there is no errors. Then go to link, our file name is access number 1.obj, the file ASM file will be converted to object file. Enter, put semicolon, then you go to debug, file name access number 1.exe, the object file will be converted to executable file. Then put T for trace, then G for go, then D for dump. Now the program is executed successfully. Here you will see the 21 is the end of the line, because the int 21 is a service number which is executed to this command. After that, the CD, this is our first 8-bit data, this is our second 8-bit data, that is N1 and N2. For adding these two data, you get 52 is the resulting bit, the carry is 1. Now go to check whether the answer is right or not. Go to open calculator, clear. Our first data is CD plus 85. So our answer is 152. This is our resulting bit, this is our carry bit. Okay, so this is the answer. This is our first exercise for adding two 8-bit data. Okay, thank you students.